Good afternoon to all. In this video we will continue with the CDC Gray code encoder. Last we see the theoretical and the RTL code for that. I just revised some RTL code for the minimum glitches. So first we start with the overview the all the codes, then synthesis, then resimulate on the synthesis part of CDC Gray encoder with the gradual increment of the values, and one of the values as a data which has more than 1 bit change. So in that case what we get at the outputs in waveform ways. Okay, so we start with the file list first. So as you know, our file list reside in all files.txt. So these two codes okay, this is our main code, so I just activate it, and this is our test bench. This is for synthesis, and this is for the reference library. So all other codes are not required, only the Gray code encoder and the test bench for the Gray. So this is for the RTL simulation. So we first check the Gray code encoder, in that all the modules are reset, like double flop synchronizer, then binary tree Gray. I just put one always block here to minimize the glitches due to this conversion. So I put one negative edge for pre-computing and the positive edge for the output latching. Same case with the Gray to binary for the pre-computation and the latching the output. In CDC Gray encoding, it is our top level. We combine all these modules, and one test bench is there. One test bench in this file also is there, but we are not using that. What test bench we are using here is TB Gray. So in this we instantiate our top and place some values on the binary input, like we are keep the change in one bit. Okay, so it will be minimize the glitch. So we try our best to have simulation with this using the VCS. This is RTL simulation, so it will be make there is already there. So we just wrap up these things because it is already 2-3 videos based on the Gray. Okay, so that we can move forward for the further CDC design solutions. So Control A, Control 4, then Control 4, then F5, and hit 5. So in this we get the what we are sending. This is our binary input, okay, and this is our binary output. So 05, 05, 07, 07, 0F, 0F, 1F, 1F, like that. So this is RTL for the CDC solution using Gray encoding. Okay, so for the rest of the thing, for the synthesis, we do the design vision arrangement for it. So for design vision, there is one tickle file there, so I think we need to check that tickle file first. Okay, in this you just source we are referring this in 90 nanometer RTL. Okay, code. So the logic seen as this kind of thing, as similar to our structure that we, this is a binary to gray, then double flops, then gray to binary, and these are the outputs. Okay, so these are the inputs and clocks. So we move back to the synthesis simulation. So we go back to our file list and change the required files for the synthesis. Okay, as we are placing the RTL files right now, so we move back to the VCS, then open the all files. Now we are required the synthesis files. These are the RTL files. We need a test bench. We need for the synthesis. We use this encoded synthesis file. We just created that. We will see. We can have the overlook of that result. CDC 90 CDC coding .v. So this is a binary to gray, this is double flop, this is gray to binary. Okay, and this is the top level CDC Gray Encoding. All the modules are instance here. So we quickly run the simulation on the synthesis part. So the command will be the same because we had kept the test benches same for it. Okay, I think we need to change this is for, okay, we need a file list. Okay, we need a library references because this is for 90 nanometers. So we need test bench, then synthesis code, then reference library for 90 nanometer. Okay, that's it. Okay, so again Control A, Control 4, and F5, fit F. So in this way we can simulate the RTL, and this is our binary input and this is our binary output 05, 05, 07, 07, 0F, 0F, 1F, 1F, like that. So we try our best to, because these are the binary values such that there is only one change, so it is looking very clean output. Okay, and we just resimulate it with the more than one bit change, like let's say 1F, 3F. So instead of 3F we place the 2F here and 3F here in the test bench and recompile it and resimulate. Okay, so we open the test bench, in that there is some values 1F. In spite of 1 bit change, I just change the 2F here and 3 or FF here. So in that case, what kind of waveform we get from this? Okay, that's it. We just recompile. This is with the synthesis code. Just Control A, Control 4, F5, press F5, and F. Okay, I think F5 zoom fit. So as we change the more than 1 bit, like 1F, 2F, it has 2 bit change, so it create a glitch at the output side as well as the input side. Sorry, this is the input. Okay, so we are seeing the glitches if more than 1 bit change is there. So I don't think it is good for the multi-bit data transition. It is can be used for the counter values to send or receive. So we remove these changes and let's see what happened in the simulation again. So sometimes this kind of iterative process help to understand what is going on there. If we are not getting in one run, 3, 2, and so we can alter the some frequency numbers here. Let's say this is 7, this is 5. Control A, Control 4, then F5, press F. So as we see, there is no issue with this because this is the input. And this is output. So 05, 05, 07, 07, 0F. So it looks okay, even though we swap the clock frequency fast to slow, slow to fast. Okay, I hope you got the point, but definitely it is not useful for transacting a data that has more than 1 bit change. It will looks to be okay in RTL simulation, but while going for the synthesis simulation, I found some glitches at the output side. Even though I place a proper latch at the output side after the combo of gray to binary, still I saw the glitches. Hope you find this video useful. We actually move on for the CDC design solution after this gray code encoder, because gray code encoder stretch 2 or 3 videos. Actually in 15 minutes I can stretch all the design theoretical aspects, then RTL simulation, then synthesis, and then again synthesis on the simulation on the synthesis. So that is little bit time taking. And please subscribe my channel, and thanks for your support. Now we are at the 100 subscriber. We hope people join us and make a comment for the further feedbacks and further videos, and please make a comment for the any improvement or like that. Thank you.